Good afternoon. I'm pleased to welcome to the STEM Garden the third Q&A session with special guest Chiung-Wei. Today we will be learning about her involvement in the STEM field as a PhD student in nanoscience at the University of North Carolina. If you have any questions at any time, please type your questions in the chat and we will answer them towards the end. This session will be recorded and uploaded to our website for your viewing pleasure. So if you know anybody that couldn't join us today, or if you would like to look back, rest assured that it will be available for future reference. The STEM Garden is an organization that strives to provide students with free resources in the STEM field to expand their knowledge, whether it's free tutoring to students K through 12 or providing free meetings with influential people in our community, such as this one. Our goal is to immerse students and cultivate a brighter future for kids in the STEM field. She is a perfect example of someone who is an influential person in the STEM community and shares an important goal with the STEM Garden. Now we will hear directly from Chiung-Wei. Please introduce yourself to the viewers.
All right, no problem. I'm gonna share my slides. Oh, can you share me the access?
Yes.
Perfect. Thank you so much.
No problem.
Yeah. Is that good to you?
Yes.
All right, so thank you so much for introducing me. So I'm very happy and excited to be here and share some story about me. So I'm Chiung-Wei. I will be spending some time in sharing my story and journey in STEM. And then I will talk about what I'm doing for PhD and how the story is look a little bit different from others. And then I'll be happy to take in any questions. And also feel free to stop me if something comes up, all right? So here's just a sneak peek about what I'll be talking about in regarding my background and what's the turning point for to do a science, to pursue science and do a PhD. And then I will touch on briefly on my PhD work and the outreach inspiration from science. All right, so who is Chiung-Wei? So I'm a researcher, a scientist, and I'm also a mom of two. And I'm also a first generation immigrant and graduate student. And then PhD, I also work on science communication. So of course, I don't normally wear these titles and working around and announce what I'm doing to people, because I do this because I realize along the way, I figure out I wasn't really exposed to a lot of roles when I growing up or doing in my education. And I want to just let people know that it is fine, particularly for girls and women, that it's fine and to represent yourself in the way that you want it to be. Just because if you are still learning, it's still fine that you can pursue whatever you want to be and just tell people, and it's fine to speak up. So where did it all get started? So I came from Taiwan. As you probably can tell, I'm a foreigner. And so this sweet potato shaped island is my hometown. And here I show you just a very quick, this is the capital Taipei. You might or might not heard about it. And in the middle is the iconic Taipei 101 building, which has been one of the tallest skyscraper in the world. Of course, it lasts for like a couple of years, and then now just in the top 10. So I've been living in Taipei for a couple of years, and it's a very hustle and bustle city. To me, it's like New York to me, because it just has everything. And compared to the city hustle bustle, I actually grew up in a more like a rural side. So here's where I grew up in, and my childhood was just filled with this blue and wild sky and playing in the rice field and biking, or go to the sea over the ocean. So this is a very different just across the country. So in 2015, I traveled 1,000 miles and then arrived at North Carolina. So now I work in the University of North Carolina in Chapel Hill in the Department of Chemistry. So this is the building of the chemistry, and as you can probably tell, it's pretty something similar with my hometown, because the blue sky and just a very greenery city. So it's kind of just every time. So I kind of like fell in love in the first sight when I first visited here, because it just reminds me my hometown. And then kind of that environment and surrounding just kind of become part of my motivation to be happy living in this place and then doing my work. So I think that whenever you want to pursue anything, kind of take the surrounding environment into consideration, because if you feel right about you whenever you live in, it's kind of very important part for like driving you through to everything. So what leads me here? So my story is a little bit different. So unlike many other people, they would do a PhD after undergrad studies, or maybe take a few gap years. So I didn't do my PhD until I was 30 years old. And because I think it has to do with the cultural background and educational system in the country. And I do have a lot of struggles along the way when I like revisited my past. And so in Taiwan, when we want to enter a college, we have to take the standardized test. So that's a test to evaluate your subject performance, like chemistry, physics, things like that. So that kind of pushed us in college, in high school, we have to choose between if you want to pursue art or you want to pursue science and technology. And at that time, I was pretty stubborn. I just want to go after science, because I was so inspired by watching the National Geography document, so seeing all the scientists and working in the field and interacting with the wild animals. But at that time, my family, particularly my parents, they didn't really like the idea of me going after science, because in their mind, girls are not very, science is not very good or suitable for girls. And at that time was also, there's a lot of fighting and argument. And now I now kind of realize that the fight of me have a space in science and STEM generally has started way back when I was in high school. And now looking back, I just thought it's not really unreasonable for them to think about that, because it's kind of like 10-ish years ago. At that time, people don't really talk about girls in science or women doing science. And that's kind of their mindset when they grew up and in the society. So that brings me to my point is, I think, yeah, it's important to have a representation and advocate for women in science and the representation, and also to break the bias in the society, because that's how people view for us, right? So I kind of so that's the struggle in very young age, and then I kind of survived and then get into college and study in chemistry. So college is another whole different world from high school. And then I didn't really worry about whether I want to do science or I want to pursue a PhD, because no one just talked about that. And then at one point in my senior year in college, I get involved in a research lab, and that lab is doing spectroscopy, basically just studying the molecules in the air and study how they interact with each other with light and with the lasers. So that was very new to me, because I have no idea about that. I just thought that, wow, the lab is so cool, and there are so many equipment I have no idea about. And the senior lab members, they are just like look like on top of the world and knowing what they are doing, and they have taught me a lot. So at that time, I think, yeah, I think research is cool, and science is, and then doing advanced graduate program might be work for me. So then after college, I graduated, and then I decided to apply for the master degree. Master degree is probably not very common in here in the States. So master degree is basically is part of the graduate program, and it's like a PhD program. It's a less dense, kind of more like a 2 years-ish program. But what you do is really similar to a PhD. So you take some course in the first year, and then you do research and then write your thesis. That's basically what I was doing. So at that time, I thought it's a good idea because I continued working in the same lab. It should be very easy. But turns out the transition wasn't really comes easy, because what happened to me is that in the first semester, I kind of suffer mental health. And of course, in 10 years ago, there's no such thing, there's no term about that. And I was like, I knew I was suffering from something, but I didn't really consult with anyone because I just thought it's probably my problem that I have a poor ability. And because everyone seems like they can work on themselves and then just graduate and doing fine. So what happened is I started to have insomnia, so I couldn't sleep in the night, or I would get very irritated and get out of bed just in the middle of the night. And I was screaming silently because I don't want to perturb my roommate. And that kind of continued for a semester. I also avoided my advisor. So whenever he came in, I would sneak away from the back door, just try to avoid any conversation with him. So, and then the breaking point kind of happened when I returned from a week-long holiday vacation. And that's important because it's kind of the first concept I engaged with science communication, even though I didn't know that's a thing at that time. And I didn't know what I was doing then. So what happened is this is a holiday, so I went back to my home and my original home where I grew up. So I have more time for myself. So I kind of pulled out the paper and then started to read and sentence by sentence, and then started to summarize with my own words and write a schematic in my own way. So that helps me to understand what's going on in a scientific paper. So without me really knowing that, I was kind of doing a science communication, communicate with an audience, but only that time the audience is me because I want to understand what's going on. So that kind of improved my communication with my relationship with my advisor. And so everything kind of improved and making progress. And then I graduated in the expected date. And then, but just toward the graduation, I was exposed to another new idea, which is studying a PhD and studying overseas. And this is also, again, a new idea to me because, wow, no one really talked about that to me and discussed the possibility. So it took me a while, and then I decided, okay, I will wait and see. After graduation, I get involved in another lab, so doing like a microscope and more biological side, because I want to kind of test and see if I can really push myself to doing more research. But it didn't really end up studying a PhD because at that time, I think at that time the motivation was not strong enough because I wasn't surrounded with an environment that can be so supportive and encouraging. So I kind of just doing on my own self, and if I don't have any support, that's kind of weighing down the motivation. And also my boyfriend at that time, who is my husband right now, he's also not very interested in this idea. So I kind of just, okay, I will wait and I will jump into the industry and see what's going on next. So I spent like 3 to 4 years in the industry. I work as an engineer, and mostly the company, they manufacture the liquid crystal display. So basically whatever you see on the monitor, so like the monitor at your laptop or the monitor for your cell phone. So this is the screen that we were producing at that time. And it was very fun and rewarding experience because not only I can use my professional in chemistry, but also to learn how to work as a team and to communicate and advocate for myself and learning and climbing on the career. And then just when I was about to 30 years old, like 29-ish, it kind of had another turning point because you will see at that point, people around you, your colleagues, your friends, started to buying a house or getting married. Also, I get married at that time, but they are like starting to have babies and buying a house, buying a car. And we kind of reevaluate ourselves if this is the lifestyle we want to pursue. And my husband at the time also have this personal crisis. So we kind of have a discussion and then quickly coming to the conclusion that we want a change. So that leads me to now that so I'll quit the job and apply for a PhD degree. Then I'm here to do the PhD and then doing a lot more things. I'm gonna show you a little bit in the few slides. So what I'm doing in my PhD mostly is I study, as I put it in the introduction, I study the tiny shorter length scale and how it can impact the larger functional. So we study the structure-function relationship in matters. And particularly, we want to focus on this inhomogeneity property. So what is inhomogeneity? So I put a picture here. So this is a M&M chocolate factory where we traveled a couple years ago in Shanghai. That is very fun factory. So they produce a lot of different kind of chocolate. And here you can see on each tube, you can see a lot of small circle and some of them are more like elongated. And then you can see there are different colors like blue, red, and maybe it has to do with the flavor, or maybe not, we don't know. And so now you can clearly see what's going on in the picture. But imagine if you stand up and then you step back 5 meters away. Can you imagine you can still see this kind of difference? You can tell them apart? Probably not, right? So that's where our research came in. We want to study this different distribution of inhomogeneity in a clear way because the material we are particularly interested in is at a nanometer scale. So a 1 nanometer is 1,000-fold smaller than your single strand of your hair. So that's very tiny. And then here I shows you just from the image from the atomic force microscope, which I will show you later on. You see there's my mouth doesn't really work, so I'm trying. All right, no, right. So the nanostructure slides, you can see some irregular shape, and if you see some brighter line, that could mean that this thin flakes kind of have some edges, so they kind of come together, or can be like a self-folded and then become very irregular inhomogeneity property. So that's one thing we are interested. And on the right, you can see this is actually a fibril. So that's a part of the structure in protein. And this biological is way more complex. And then, so we need a very special tool to study that. And to study this kind of very small stuff, we need a spectroscopy to know what's going on, what's the composition in that kind of stuff. So in our group, we use spectroscopy to study what's composed of this material. So spectroscopy is a study to study how the light interact with the matter or the material or any object you are interested in. And spectroscopy is very useful because it produces a very unique signal for every molecule you are studying in. So in the middle, I show you a spectrum, and on the top is a water molecule. So like a water molecule is a 3-atom molecule, and it can have some stretches, or it can have some like a symmetric stretching, so getting elongated at the same time, or the other is the asymmetric stretching. So these are very unique from anyone else, from the other molecules, so we can view it as a chemical in fingerprints. So like in your fingerprint is probably not the same from others, right? So that's the spectrum is very useful to identify each unique molecules. But it's useful, but it has a very critical limitation, particularly when we study this nanometer length scale, because it has diffraction limit that prevent us to distinguish these nanometer properties. And diffraction limit is actually proposed by the Germany scientist Ernst. So this is the actual memorial for him. And then on the top in the stone, they're actually carved with the equation he mentioned, he hypothesized. So I want to bring your attention to the D and the lambda in the numerator. So basically what it says is, if you want to differentiate two objects, and if the separation between two objects, between two close to each other, then at some point, you just cannot tell them apart unless you are using a very short wavelength to tell them apart. And that's very inconvenient because very short wavelength means very high energy. And then it doesn't really provide you a lot of chemical information. So that's where our study comes in. So nanoscopy is pretty relatively new concept. And then if you want to correlate, you can think about, instead of a microscopy that study micrometers length scale, like a virus or your hair, then the micro become the nanoscopy. And it can break down to two parts. One is the atomic force microscopy, and then the other is spectroscopy, which I just mentioned about. So what is atomic force microscope? So it's a sensor that can touch the sample. So we will use a very sharp tip and then bring it to very close to the surface of the object. And depending on the tip, the interaction between them, we can detect and then get a profile or get the property of the surface. So just imagine if you use your fingerprint and then you touch touch across a surface of your object, for example, the keyboard, and then you can probably feel the texture or the height and maybe the temperature of the things you are touching, right? So everything you feel just through the information just through your fingertip and then shoot into your brain, and you can sense anything from the surface. So that's the similar analogy. And then this is how it works. So, and noted it's not to scale. So the FN tip is really, really tiny, and I will show you a picture of that. So actually, basically it just means whenever the interaction, whatever happened, changes in the interaction between the tip and the sample, anything changes will be detected and then go into the computer, and we can go do some more analysis. So here on the left, I show you this is actually a box of the FN tip. And this is my fingertip as a scale length, so it's very tiny. And the tip you see here is actually located at the very end of this box. So I circled on the red circle. You can probably not see the tip because it's like a micrometer wide. So under your bare eye will just kind of see the reflection, but you don't really see on the tip. So on the bottom is the like a image to enlarge what the actual tip look like. So very long tip, and then there's a very sharp apex at the end of it. And on the right, I showed you an image that's actually from a real scientific paper. So that's published in by our group. So what you see is the dashed white line is actually a profile from the gold to the mica, and then we can actually differentiate the nanometer scale height. In this case, is a 5 nanometer. So the second part is the spectroscopy, which is very useful, as I mentioned, to distinguish the molecule, right? Which molecule is what, and then how they interact with each other. But how do they combine to each other? So just very straightforward idea. So you have the AFF tip on top of the molecule you're interested, and then we shine the laser light on the top of it. And then whatever the light has interaction with the molecule, then we collect the photon afterwards, and then we can detect the molecule, the chemical information. In the meanwhile, oh, okay, there's a notification. And so in the meanwhile, we can have a very high spatial resolution and also have chemical information. So that's very like a new research area, probably 20 years old history. I know it sounds very old, but in research, the lab scale is pretty new. So that's very exciting. And then here I show, do that. Oh, yes. And then, so it's just the image of how it actually looks like in a real world. So that's the real tip from the image, from the optical microscope. Wow. Oh, all right. I'm sorry about that. And so this is the real tip, and then I just shoot different wavelength of the light. So that's from the red, green, and blue. It's always has very fun to look at that when doing the experiment. And so this is another example. So it shows you when the tip is really give a very enhanced signal when we incorporate this nanoscopy. So here I shows you just a video of how it actually works, and you can also to see how the length scale is actually look like in the real life. So it's actually a commercial equipment. So this is the outside. Then when you zoom in, you will see how the sample was scanning. So that's the stage that put in this with the sample and then goes in. You will see how the tip is really on the short length scale compared to the sample. And then, just as mentioned, we shine the light on the sample, and whatever interaction because of the inhomogeneity on the surface on the sample, we can detect that. And then during scan, we can see the panorama view of what's happening. Yes, they are very tiny, so we always need a tweezer and have to be very careful not to blow and then the tip just fly away and $1,000 or $200 will just go. All right. So that's it for scientific side. And oh, one more slide. And I'm here just show you, it's a really fun and rewarding experience working in a lab and working as a PhD student. So here on the left is me working on the AFM. So the AFM is really a compact equipment. And then the second one is on another AFM equipment. And on the background, you can actually see this is the image of the AFM tip on the top surface or from the side view. And the third one is not really directly correlated with my lab life, but because as a mom, have children surrounded when I try to work is always happening. And because at that time, my son was about 3 years old and who is always very interested in what his mom is doing. So what he was doing is he just tried to read alongside with me and point to actually it's a spectrum, but he said it's a mountain. So I thought it very cute, and so I put here, and then on the back is my 1-year-old daughter. And then in PhD life, you just have to go into a different conference, although it's not happening right now because of the situation. So this is the American Chemistry Society, the Moscow ACS. Visit my presentation poster on the background. And on the right here is one of my very early project. And we don't pursue the project actually because we are doing another experiment. But I feel it's a very fun process because I built the equipment from ground, and I'm always fascinated by how the light can interact and then give you this like a very bright color collection. So that's almost the PhD life, and I want to touch very quickly on, because I feel like doing a PhD is more than only doing research and stay in the lab. And because for me, as I mentioned in my master degree, I kind of doing science communication to fix my problem, because I found effective communication can actually have more impact because it has affect my life, right? And not only my life, I think it will have more impact to the society and the whole world. So I was doing like a couple years in already. So doing more like connection and increase the visibility. So I mainly focus on science writing and involved in organization. And recently I'm more involved in media, self-media to boost the visibility. So this is communication and leadership, and this the science communication and writing club just on UNC Chapel Hill. The Pipette Pen is an organization to expose graduate student and postdoc to science writing and communication. And then this is my very first article I wrote back in 2017. So the story is that I was like, I want to do a story, but I don't know what I can really talk about. So I kind of took my research as an inspiration. So at that time, I talked about nanoparticles, which happened to be one of my projects at that time. And so it was looking at the sunscreen, but actually I was talking about nanoparticles, the science inside the sunscreen. So, and then after that, I continue to push myself to write more, and also trying to get more involved in the communication board members, so I can like get into more behind the scenes and doing leadership to learn more about how a community can provide vision and to the society and across the campus. And just one last slide is more recently. So I found that the social media is really effective and very powerful, and unless you have to do it right. So and that's how the STEM Garden found me on the Instagram. So Instagram for me is more like a creativity place, so I can talk about my science and also to contribute, to add value to other people, what I have learned. So for example, I recently found that I have been involved in writing for a while. So I think I can maybe to contribute back to organize and my thoughts about science writing and the structure. And also I'm building my blog to kind of touch on science as a mom and the lifestyle overall generally through science lens. And this is a very fun process because I get to connect it to more people. And then get to more people means more inspiration for yourself. And then I could generate more idea that could really improve and then impact other people's life or opinion. So that's me, and thanks for listening and coming here. So if you wanna like connect, I have my Instagram handle here and my blog website, and then I can also be connected with my email. And just one more message is I feel like life is full of possibility, because just along the way I find that I can actually do a lot of things, but only I have to recognize and then start to, and also continue to keep my mind and my brain and my mind open to a lot of possibility, because no one knows really what's on the other side that when you overcome something.
Yes.
All right,
Thank
that's
you so
me.
much for everything that you said. I honestly loved that idea of nanoscience. I love it.
Thanks.
So one of our viewers said, do you think nanoscience can be used in other fields? If so, can you give some examples?
Yeah, nanoscience is very popular, and I can actually give a lot of general field. So for example, just for my lab, we kind of touch on a lot of materials. So in semiconductors or on biological side. And then I myself also doing solar cell. So normally people with, because every technology is actually composed a lot of steps. So you have the raw material, and then you have device and the package and everything, and you connect with the electric circuit. So what we are doing is the very front end to study the fundamental characterization, because like what I found is sometimes we don't, when there's the end of the performance is not working well, but we don't have the, if we don't have the tool to examine what's really going on, then it's really will be hard to tailor the performance and the properties. And also, I have been studying organic semiconductor. So what I can give you this example because it's an interesting question is, so at that time, I studied two isomers of organic molecules. One's N-time, one's N-syn. Just depends on how the atoms oriented with each other. So what people have found is that if you separate the isomers into two different devices, they work fine, and it can like increase a lot of conductivity. But if you mix the isomer together into a film, and then what people found is that performance just decrease. And then, but we don't, in a manufacturing side, we don't want to put too much effort to separate apart, because when you synthesize the material, it just by nature will produce a mixture phase. So it has to be, if we can solve the problem, then we can save a lot of energy in the production. So what I found is my spectroscopy is we found that actually there's a lot of heterogeneity happening here. So that could leave some tips and guidance to the synthesize side, so they can design the molecule in a way that could decrease the homogeneity, so that can increase the conductivity without to actually separate it apart. So nanoscience really like a lot of field is doing that.
Yeah, definitely. Another question is, how did you relax while working on your PhD?
Sorry, can you do that?
How did you relax while working on your PhD?
Oh, how do I relax? Yeah, good point. Yeah, for now, I can say for now, because of pandemic, I try to maintain a structure, a routine for myself. For example, in summer, I get to go for a walk in the morning, and then I would do meditation before anything like a start to work. And then I will also take breaks in between tasks, like I don't do work for longer than 2 or 3 hours, because I found that it's the point that I will start to drift away. I cannot focus. So I would take a lot of breaks if I need it. And then I would just kind of stop working at 6 maybe, and then dinner, and then reading. And then in the night, I would do yoga. And then depending on if I have more work. And because, yeah, PhD or I think in every work, the work just never ends. You just have to set boundary between yourself to cultivate your personal space in order to maintain your ability to do work. Because what I found is I have been get into the trap is I have to continue to work. I cannot stop. I would just take a 10 minutes break and I'll go back to my laptop and start working. But what turns out is that burnout is really a real thing. And it's just because your brain cannot work anymore, but you still kind of try to push, so it doesn't really work. So yeah, maintain a healthy structure and then make sure you have, and I think this is for every PhD parent because parents struggle with sleep because the kids is always active. So maintain a very good quality of enough sleep hours is really important for me. Yeah.
Thank you. Another question is, how have you been working on your PhD during quarantine? Is it easier or harder?
All right, yeah, that would become a lot of different levels. So at first it's really hard because I have two young toddlers at home. The PhD, I just couldn't do anything. And my husband also struggled because he's also a PhD student. So we kind of take shifts. So like a 1 hour between, and then one watch the kids and the other kind of hide in the closet. So, and trying to do a quiet work in the closet, but it didn't really work well because in the closet, just the air conditioning is very bad. And then, so those kind of maintained for a while. And now my parents are staying with my parents in Taiwan. So they kind of give us some time and to catch up and then plan how we are gonna proceed, because I don't think pandemic will end in a very short period, probably by the end of next year. That's my hope. So we kind of have planned to kind of do more structured plan. And then so after they were traveling back to Taiwan, the past 3 months has been really I think it increases my productivity or my progress. I think the main part aspect is because I have more time with myself, and then I can do more reflection on what have been working and what have been not. And if that's not working, how do I improve or change the pattern of me working, or changing my mindset to make the path through the comfort zone so I can make more progress. So yeah, and also on the research side, it also changed a lot. Because as you can tell, I mostly work on experimental, I'm lab-based. So pandemic just means I have almost zero or very limited access to lab. And in the beginning, I just shifted completely from doing experiment to computation. And that sounds actually not sound too bad because I have some computation background and I did a little bit in before. And I also have been interested in doing programming. So over the past 3 years, I kind of doing a new project because I have to learn how to programming using Python and learning some machine learning stuff to apply that could help interpret the data that we have collected before. So overall, I think bad and good half. Yeah.
Okay, thank you so much. Are there any more questions?
Right.
Okay, if there are no more questions, then this will be the end of the Q&A session. Thank you so much for everything that you said. It was really, really interesting. Oh, there's another question.
Oh, I couldn't say that.
How has it been being a woman in science?
How has it been? Yeah. So as I say, I actually have a lot of struggle because no one actually believed I can do science, especially my parents, but I think they now just give in and whatever I'm doing there will be insupportive. And then I think I wouldn't say bias, but the stereotype kind of really break down. So I don't really find it really hard, but I do have found some problems in science is from just based on the ratio of female faculty. it's really very low, and especially when I try to look around if any female faculty or female scientists have a family, or when they study to add family members. That's kind of really like not so much people are really doing that. So I think, yeah, more encouragement, and as I talk to people and then women or girls and kind of ask me this question, how is it like doing a PhD and also raising kids? And so that's what I'm trying to do, to talk more about my experience and what's the resource or the supportive I can provide or they can look for, so that they could be less insecure. So because PhD is a very long year, like 5 or 6 or maybe more than that. And if you have done PhD and then start to think about have family, then it would be like a very, very late age. And most people don't want to do that. But yeah, the balance between when is a good time for women to have a family or continue to pursue the career. In my mind, I think if it feels right to you, then you should just go ahead, even though there's a difficult. But with the difficulty, you just have to reach out to people. They could provide you suggestion or resource direct to you that could help you along the way. So yeah, I think that's my answer.
Okay, thank you. Yeah, like I know it's hard for women in science and the statistics are lower for women. But it's great to see that you've been making such progress. It's amazing.
Thanks.
No problem. As I was saying before, thank you so much for everything that you've been saying. It was really interesting to learn about nanoscience because personally I don't know that much about nanoscience, so it's interesting to hear more about it. Um,
Yeah.
Thank you so much. If nobody else has a question, I'll wait like a minute. Okay, no more questions, so I'm gonna end the Q&A here, but thank you so much.
Yeah.
We'll be in contact.
Okay. All right. Thank you so much. Have a good night.
You too. Bye.